We are going to be graphing linear inequalities. So we already know the concept of how to graph a line. So that's one thing that we're going to be using. So in this example, we have it in slope-intercept form. So we're going to use that prior knowledge to help us draw a line. We're going to first find the 2 points. So we have a y-intercept at -3, and we have a slope at -2. So again, remember, slope would be rise over run, so we could go down 2, run of 1, or we can also go 2, rise of 1, and left 1. So I am going to use this. So our slope of 2 would be a rise of 2 and a run of -1. We have our 2 points. Now, we are doing inequalities. So what this means is there's more than just, before we only had points on the line that made it true. Now we're going to have more than those. So what we need to look at is next, we need to determine what type of line is this. Will the answers to this inequality lie on the line? Well, the best clue is looking that we have equal. So what that means is if we have the equal part of our inequality here, that means the line is going to be part of our solution. And therefore, we are going to draw a solid line. The next step is we need to know where we're going to shade. Now, a couple of things that you can do is choose a couple of points above the line or below the line and find out if those points make it true or untrue. We're going to shade to the parts where that is true. So like for instance, if I chose 0, 0, which is always a good reference, if x is at 0, that gives us -3, and if we're at 0, 0, our y would be 0. Is 0 less than or equal to -3? It's not. So I'm going to guess that we're going to be shading downward. So let's try another point. And again, make it easier on yourself. So what if we chose -4, 0? So if that's -4, that would make that 8 minus 3 is 5. And our y is at 0. Is 0 less than or equal to 5? Yes, it is. So we are going to be shading our graph downward like so. Now I do have another little shortcut or thing that you can remember. If it's in slope-intercept form, notice our inequality. The smaller part is pointed to the y. That means the y's, the smaller y's, are going to make it true. Another thing you're going to come across is a linear inequality that's not written in slope-intercept form. Now you have 2 options here. One's a little faster than the other. You could change this to slope-intercept form, but it's going to require some algebraic work. Or, remember, we can also draw a line representing this equation by finding our x and y intercepts. So if y were 0, we would have 4x is less than -12. We would then divide by 4, and we would end up with x is less than -3. We're not really concerned with the less than symbol right now, so our x-intercept is at -3. We're going to do the same thing for our y-intercept. So if x is 0, we would have 3y is less than -12. We're going to divide by 3. Our y-intercept is actually at -4. Now, notice that we do not have that equal part. So what that means is the line is not going to be part of our solution. And to represent that, we are going to draw a dashed line stating the fact that this line, any point on this line, will not make this inequality true. And now, again, we're going to have to pick some points and find out, are we shading upwards or downward? So again, 0, 0 is always a good place, unless, of course, the line goes through it. So 0 plus 0 is 0. Is 0 less than negative 12? No, it's not. So let's try another one. What if we went to, let's say, negative 5, 0? That would be negative 20 plus nothing. So negative 20 is less than negative 12. This one we're also shading downward. We also have some simple inequalities like this. Normally, x at 1, we would go here, x at 1, and x is greater than or equal to 1. So we're going to have a solid line at x at 1. And we are talking about all the x's that are greater than 1. So in this case, we are going to be shading this graph to the right. Our next example, we have y is less than negative 1. So we're going to go at our y at negative 1. Notice negative 1 is not going to be part of it because it's not equal, so we're going to have a dashed line at y at negative 1. And y, we're talking about everything, all y's that are less than negative 1. So we will be shading everything downward from this dashed line.